So with density, it's an intrinsic property of the material that relates mass and volume of the material. So you get mass and volume. Density then also introduces a new thing, as we now have a numerator and a denominator, and we're relating two different unit systems, which means what is density? We do have an equation here, but if I just get rid of the word density, it is a fraction. Where would I use a fraction? It's a conversion factor. Okay? Density is just a way to relate mass and volume so that if I have an individual substance, I can convert its mass into the volume of that object. Okay? So all we have now is a new conversion factor that you would then be required to manipulate and use. Okay? Before we get into the manipulate and use, the units for density. Depending on what phase you're looking at, you may see the units change. When we look at solids and liquids, typically the units we're looking at are grams and milliliters. Why would we pick grams and milliliters? Right? Milliliters is not a core unit, so that doesn't count.
Grams and milliliters directly.
What was that?
Because they're small.
The grams and milliliters for most substances, if you went to measure a mass, the mass that you would measure in a reasonable amount would be gram amounts. Okay? Same thing for the milliliters. To measure a reasonable amount of a substance, milliliters makes sense. Okay? That's why those unit systems are picked. We could do kilograms per kiloliter, okay? Or kilograms per liter. Okay? That is going to change some of the numerical values. Okay? In changing those numerical values, it'll probably take that density value from being something close to 1 to maybe being something close to 1,000. Which is easier for the human brain to understand? 1. So we've also picked units that give density values numerically something close to 1. Right? Ideally, we want to be sandwiched between that 1 and 10 range. Why? Fingers. 10 fingers. Okay? That's where our brain can kind of manipulate and deal with the number relatively well. What happens if we go up to the gas phase? If I went to the gas phase and used grams, what do you think the mass would be? Okay. Number. Okay, let's go through and take a look at the solid. If I was to represent the solid, there's one molecule of our solid. How do I make it look like a solid now? Do I need more than one molecule to be a solid? Yes. Okay, where do I put the next one? Right? That would be my description or picture of a solid. What would happen if I now moved up to water, a liquid? Okay, these get a little bit more spaced out. They're still pretty close. Okay, sometimes they'll still be really close. Other times they'll be a little bit more spaced. Right? What happens when I move to the gas? What's contributing the mass of this? What's contributing to the mass? The molecules. How many molecules am I going to be able to fit if they're very closely packed? A lot or a little? A lot. When I go up to the gas, how many molecules am I going to be able to fit? How big? It's the same volume. I'm not going to have a lot of particles in there, which means what happens to the mass value? It goes down. It goes down significantly. It goes down somewhere on the order of 0.009, I'm just going to say 17. What becomes a problem with reporting that number? Is that between 1 and 10? No. That number is now so small that it might be difficult for us to interpret. It also includes a bunch of insignificant zeros as placeholders. Okay? So we could try and truncate this. Truncate's the wrong word, but abbreviate this as 9.17 times 10 to the negative 3. So cool, I've now got that 9. That's 1 through 10, so that's reasonable. But now I have powers of 10. Do I like powers of 10? No, so also bad. So what could I do?
Convert to
0.9 times 10 to the minus 2 doesn't solve anything. It's also a number lower than 1. It's close to 1, so that's reasonable. What is 10 to the negative 3? Say that again. Milli. Instead of reporting this as 10.17 times 10 to the negative 3 grams, I could call it milligrams. Okay? So when I look at densities for gases, I change the unit system. Why? So that I can change the numerical value to get it back up to that 1 to 10 range. That becomes challenging, because if I now compare this, well, 9 to 1, which one's more dense? Which one's the bigger number? Most people, oh, well, 9's a bigger number. Air isn't more dense than water. You have to also watch out for the unit system behind it. Does that make sense? So we will manipulate the units on density depending on what phase we're in, so that the numerical value we get is in that 1 to 10 range, typically close to 1.
Can you pressurize gas into like a tank? Can you put those molecules closer?
What happens, and so this is now moving into chapter 13, which is this unit, so I'll accept it. Let's take that gas particle and let's shove it into a tank and let's pressurize and keep pushing it down. And we're going to push those things closer and closer to each other. What'd you just make?
Solid.
Your bomb says the container explodes. Container doesn't explode. You made a liquid. When you shove gas into a container that now doesn't explode, right? And if you force enough gas in there and get them close enough to each other, what happens? It becomes a liquid. You can, helium I think is a trickier one. I think you can, I'm like 90% sure you can condense helium. And I think its boiling point is 4 Kelvin. Okay. We haven't talked about temperature scales yet. That's also the tail end of this. But 4 Kelvin is very, very, very cold. Okay. To give you an idea, right now we're at 298 Kelvin. That's pretty significant difference. Okay. So yes, we can force gases, force them closer to each other. By forcing them closer to each other, what have we done? We just turn them into a liquid. They're no longer a gas. We've changed those physical properties. Okay. So we will go through and shift those units depending on what we're looking at. Okay. To get an idea of that, let's take a look. Here's some example solids, liquids, and gases. Take a look at the numbers. 1, 13 ones, 20s, ones. They're all about the same number. That would suggest that gases have the same density as our liquids and solids. They change the units. Okay? So when you're making that comparison, you have to be very careful that you're comparing the same thing. Okay? Comparing kilometers to miles doesn't work as numerical values until you make sure you're comparing the equivalent of miles from kilometers, right? You have to have the same unit system. Okay? How do we use densities? We've got a graduated cylinder here with a bunch of liquids and solids in it. What can you tell me about solid 2, the green one?
More dense than water.
Okay. It is more dense than water. How do you know it's more dense than water?
Sunk to the bottom of the water.
Okay. If it's more dense, it sinks. This is why when you throw a rock into water, what does it do? It sinks. When you throw a witch into water, sorry.
What kind of witch?
Sorry, now I distracted myself. I don't know. It sinks because it is more dense. One of the common conceptions is that it's heavier. Is a boat heavier than water?
Yes.
Depends how much water. You mean the volume is also important? Yes. You're not comparing the masses, you're comparing the densities of the two. Their relationship between their mass and volume. Right? So when we go through and look at solid 2, we know it is more dense than water because what did it do when it hit the water? It sunk to the bottom. Okay? What else can you tell me about solid 2? It's less dense than liquid 2. Why? It's floating on liquid 2. Okay? So we can create systems like this so that we can actually visually see this. Becomes a little bit tricky sometimes to nail down, but bartenders are famous for things like this. Right? That's exactly what they try and go through and do with the varying levels of alcohols and sugar contents of the drinks to get you weird effects. Okay? They have an also added difficulty in that everything that a bartender is dealing with is they're all water soluble. They should all mix with each other. Okay? Chemists could make this more difficult or easier because we could pick substances that don't mix with each other. That makes it a lot easier. Okay? Kind of make sense? Okay. Just learned a little bit about bartending. There you go. Because you're all 21 and that was perfectly sensible to do. At least 5, right? Is there a quorum? So, you'll be expected, as you saw in the practice exam, I believe, to rank those densities and be able to tell me where a substance was. So if I told you a substance was... Never mind, I can't do that off the top of my head. Okay? Look at the practice exam because the old practice exam is going to be helpful for that. Okay? All you're being asked to do is now ultimately just rank your densities. Okay? No, and I've never bartended, so. But I have attempted to make those layered drinks. It didn't work out so well. So, we'll throw this out there because we're about to start some conversions. It's okay. Only a fraction laughed, but that was the kind of the point. No. Calculating density. Okay. What is the density of a platinum nugget that has a mass, 224.5 grams, and a volume of 10 centimeters cubed? Okay. There are technically 2 questions here. What are the 2 questions?
What's the density? Ounce per liter.
There were 2 questions. Give me density in grams per centimeter cubed, or give me density in pounds per liter. So there were 2 questions being asked. How many of you think you can do the grams per centimeter cubed?
Yeah, pretty easy.
Yeah, okay. Let's walk through how I would recommend you do that, just to give you an idea. What are we solving for? Am I given grams? Yes. Am I given centimeters cubed? Yes. Where should I place the grams? On top. So I'm going to go through 224.5 grams. What am I going to put in the denominator?
10 centimeters.
Okay. We heard 2 answers, which is cool. One suggestion was to put 10 centimeters cubed in the denominator. And I would argue no. Okay. I would argue what you should put in the denominator is 1. Okay? Because what I'm trying to input here is a true value. The true value that was given to me was 224.50 grams. That was the mass of the block. Okay? I don't want to do an interpretation. Can you versus should you are 2 entirely different arguments. Okay? Just for the record. I would argue should, we shouldn't, because we want to input only directly true information. If you start condensing conversions, you can encounter problems. Okay? Would that give us our answer? If we just wrote 224.50 grams over 1.
No.
What's wrong with that?
Because it's still 10.
don't have centimeters cubed. Am I given centimeters cubed? Yeah. Where do I want centimeters cubed to show up? In the denominator. Centimeters cubed. What's the number in front of it? What number do I put in the numerator? 1. Okay. And again, what I'm trying to input into that is just the true value. And a lot of people have a hard time with those ones. The denominator 1 isn't usually a problem. The numerator 1 freaks everybody out. How? You can't just put 1 there. Yes, you can. Okay? The other 1 in the denominator makes sense because what was the true value given? 224.50 grams. If that was anything other than 1, were you given 224.5? No. If it was any unit other than no unit, were you given just grams? No. So that one makes sense. What happens when we move the other one? What was the thing that you were given? 10 centimeters cubed. Okay? You weren't given that in the denominator. You were given that in the numerator. By placing the 1 here, what we're acknowledging is that you need to divide by the volume. What was the given volume? 10 centimeters cubed. If I place any number other than 1, I'm now altering the given volume. Either the number or the unit. Does that make sense? The placement, numerator or denominator, is really just allowing me to say multiply or divide. Okay? If we set this up, this would then equal, what is grams over centimeters cubed? I don't want a number. What would that thing be? Density. So for the record, we have 1 over volume times mass equals density. What was the equation for density? Mass over volume. There it is. So you could go through and memorize that the density is mass over volume. That is absolutely fair play. But why? Why should I bother to memorize that? Well, it's not that difficult, Mike. That's one fact. Remember, you also have to memorize all the symbols on the periodic table. You also have to memorize the polyatomic ions, okay? The amounts of the atoms in them, the charges on them, trends in electronegativity, trends in atomic radius, the atomic charge or the ion charges for our elements, balancing out elements. Okay? You have a lot of stuff to memorize. Eventually, you're going to reach a cap and it's going to break and the whole system crumbles. It's not just going to be, I'm going to just forget the density. It's going to be, I'm going to forget everything. And what happens? We get horrible exam scores. Okay? Because, again, when you lose that last little bit, everything crumbles afterwards. Right? It's not just a loss of a single data point. Right? So I would argue memorizing this formula is a bad idea. You want to do it? That's cool. Not my recommendation. Why do I not need to memorize it? What was the process? That was a question. What was the process? Kinda, except grams over centimeter cubed. Yes, that's what I'm circling, but think more about the process. What did I want? Then what did I do? What I had, did those equal each other? No, so what did I do? I added another piece of information that I had. Okay? And note that I'm inputting the information as a single bit. I'm not trying to do that admittedly simple just substitution in. Does that make sense? Okay. So, can I clear it all the way? Cool. So let's do the harder one. What was the harder one? Pounds over liters. Am I given pounds? Am I given liters? No. Right? So I'm going to have to come up with some way to solve for those. I'm not given directly pounds. I'm not given directly liters. But do I have in the given information something about pounds or liters? Yes? What do I have?
1 pound.
I have that 1 pound is 454 grams. So I'm taking that given information and I'm now going to place that into my conversion. Okay? Where do I want to place it? And don't tell me right there where the red line is. Okay, so I want to address a couple things. Number one, the very first thing you said was 1, and I'm going to say no, stop. Okay? Pound needs to be the important part. The pound is the unit. Once I know where the unit goes, then I can place the number. Okay? The next part of that was you said you should place the pound in the bottom. Where does pound end up in my answer? On the top. Did you place it on top? No. What does that mean? Wrong placement. What am I going to relate the pound to? Okay. What number is associated with the pound?
1.
What number is associated with the grams?
454.
There's that single piece of given information. Is that my answer? What's wrong with it?
You haven't canceled the liters?
I haven't canceled the liters? I don't have liters on the left-hand side. What else is problematic?
You have grams.
I have grams. I don't want grams. Okay, so there are two things wrong with the work I've shown on the left. So I need to input that information in. Which path do I go?
Eliminate your grams first.
Okay, eliminate your grams. Does anybody want to bring in liters? Yeah, possibly. Does it matter which path you go? No, because you'll have to do both anyway, and
It's the process.
this is all multiplication, and multiplication is communicative. It does not matter the order in which we go. This is one of the reasons why people have a hard time with conversions, is because what you're trying to do is force an algorithm onto it. I just want to shove numbers in, multiply and divide out. There's multiple processes to go through and solve these. I want you to focus on the process. Okay, not repeating the calculation as shown. Does that make sense? Okay, so what do we want to do? Deal with grams or liters? Grams. Just because you said grams, I'm going to deal with liters. Why am I placing liters in the denominator? That's where it shows up in the answer. Am I given just liters? No. Ooh, this becomes challenging. Because if I go through and look at my given information, I have 10 centimeters cubed. I have 224.50 grams. And I have 1 centimeter cubed equals 1 milliliter. Liters aren't really mentioned anywhere. Do you know how to convert liters to something else? Yes. What are you required to know? How to convert liters into milliliters. How do you know you have to do a conversion? Did you have just liters? No. What does that mean? You have to do a conversion. That's why we're doing conversions. Okay? We're forced into that situation. What is the numerical relationship between those two? 10 to the minus 3 liters is equal to 1 milliliter. This is up to you on how you want to memorize it, but this is how I told you to do it. This is how I'm going to stick to doing it because it's the most consistent method. Okay? The 1 will go with our complex unit. This conversion factor, I have to memorize. The red one was given. What unit would I now have? Have I gotten rid of any units? No. So this arguably was a horrible path to go because I'm making it more and more complicated without simplifying it. Again, it doesn't matter. I'm addressing the key points. My liters and pounds are where they need to be. Okay, so now what do I want to do? Cancel one of them. Which one do you want to cancel? Milliliters. I'll agree with you on that one because it's going to bother me to go back and do grams. Okay? So to do the milliliters, okay? And notice, it's going to bother me. It's aesthetically, I'd be jamming too many pieces in and it's going to make me lose focus. That's up to you to decide that process on what sticks and works with you. Okay? You have to own the process. Okay? I for sure know milliliters does not show up in the answer, which means it needs to be in the bottom. Okay? Am I given just milliliters? Seriously? Okay? But I am given a conversion, so I can convert the milliliters to centimeters cubed. And what is that conversion? 1 and 1. Kind of a boring one, but hey, doesn't matter. Given. Awesome, I finally got rid of a unit. Okay, now what do I want to do? I don't want centimeters cubed, so how can I get rid of that? I need to put centimeters cubed in the denominator so that it would cancel. Am I given just centimeters cubed? Yep, I'm given 10.0 centimeters cubed. What do I place in the numerator? 1. Okay. I was just given the volume. Okay. The centimeters cubed will cancel. Now what could I go through and do? I need to get rid of the grams all the way freaking back at the beginning. Notice where that gram showed up. It showed up in the denominator. I don't want it in the denominator, which means my last step, where do I have to place the grams? In the numerator. Do I know the grams? Yes. It is 224.50. Sorry, I ran out of space. What goes in the denominator? 1. This was, again, a mass given. I can combine the mass and the volume, but that combination, I would argue, is a memorization of density. Okay? You're combining a step. If you do it right, all you're going to do is make me unhappy because you didn't follow my process. Okay? You can make me unhappy as much as you want as long as you're right. Don't make me unhappy and have you be wrong. Okay? That's where I have a problem. Does that make sense? Now what can we do? Now we can take all of those numbers and multiply and divide everything out. Okay? I've seen people take varying tactics with this. If you know you have a hard time separating out the numbers and the letters, that's okay. Right? Acknowledge that you have a hard time and ensure that you go through and do it. Numerator over denominator. What was in our numerator? Numbers at this point. 224.50. What else was in the numerator? 1. Thank you for the 4. Okay. What was in the denominator? 1 times 10.0 times, now I can see I'm 1 times 10 negative 3. So I can do the numerator. And I'll get 224.5, right? I did that right?
Yes.
Okay, the bottom one, I can't do that fast.
It's,
I should be able to do it that fast. Point 454.
I got 4.5.
Did you have the 10 in there? You're right. Now we can enter into the calculator 224.5 divided by 4.54, and we get the magic number of
49.45.
Don't round it. 49.4.
0.4. Whoa, hold up. I forgot the decimal. 49.449339207.
9. We'll just do that. Okay, so 49.4, I think I had too many fours, whatever. Okay, 44449. Really? Was there that many fours and nines? Okay, let's just pretend. Okay, what's our answer? What is the numerical answer? So you're telling me a density, yes, it is density, and it is in units of pounds per liter. That's fantastic. Now give me the number. 49.445. Okay, so we have a suggestion that our answer should be, and now I got to be a little bit careful on what do I erase. 49.445. Anybody want to second that? Oh, we got a challenge. What do you think it is? Why are you saying 5?
When we look at when we compare the 6 fixed between the numerator and the denominator.
Not yet. Not yet. First, why'd you get up to 49.5? Because the calculator spits out 49.44. Oh,
49.4493.
We're still going to get this. Okay? 49 point what? Why should it be 4 and not 5?
4 rounds down.
That circled 4 is an insignificant digit. The first insignificant digit dictates what happens to the last significant digit. Okay? Because it is lower than 5, we leave it alone. Okay? And so we now have a suggestion that our answer should be 49.4. So the question that I would then ask is, why is it 49.4? We have to go through and evaluate the sig figs of everything that was used through the calculation. Right? And when we go back and take a look at this 10 centimeters cubed, how many sig figs do we have? 3 sig figs. When we take a look at our mass, we had 5 sig figs. Fewest sig figs dictate it. We get 3, 49.4. Of course, all the letters come back. 49.4, what was it? Pounds per liter. We good?
Yep.
Okay. The process is consistent. Notice in this, what was this red thing? Where did we find it? It was given. Guess what happens in this next unit? No more givens. Black one, gone. Okay? You would have to know that information. That's dealing with English to metric conversions. The English to metric conversions aren't really chemistry. Those are there to provide you the context and practice of something you already know how to do, so that when we move to new unit systems that you don't know, you can focus on where to find that information instead of how do you use that information. Okay? So the rest of the unit is now, well, here's a conversion factor. Where do you find that conversion factor? How many hydrogens are in water? 2. How did you know that? If you know the formula of water being H2O, one water molecule has 2 hydrogens in it. There's a conversion factor. You just related hydrogen to water. Where was that information found? In the formula. Okay? So we will use that information and tease it out to be used as conversion factors in a solve. If you don't have a process, guess what's going to happen? You're going to be trying to get a process with units that you don't understand, which means you're going to be placing the units in the wrong location, not knowing where to find them, and start to shuffle all of the conversion factors across each other. This is why it was so important to deal with the process in the last unit. Kind of makes sense?
Yep.
Notice we're still going back over it. Why? It's not so much that you didn't do good on it. You need that practice. Okay? So we're seeing that process show up. Okay? How about this one? What are you being asked to solve for? Okay? So we heard a density right out of the gate. Well, we're talking about density. Must being asked to solve for density. Read the question. So step one, you've acknowledged that you can read the question. Okay? And a lot of people are laughing, oh, that's stupid. That's a really important step. Okay? If you don't know what you're solving for, you can't go through the process. So acknowledge and get that information down. You're now also making me a grader on looking at your exam, having to be like, I didn't key that as worth any points. But have you proven that you understand what's being asked for? Kind of, maybe. Fine, here's half a point. Okay? You're making me have to go through and take points away from you. So show your work. If you write nothing, you're not making me do anything. Okay? And that's usually what happens. When you leave it blank, you're literally saying, don't give me points. Okay, that's fine. I can do that. Write something down. Okay? So, if we're being asked to solve for grams, are we given grams in the question?
Yeah.
We're given grams per milliliter. Okay? What else are we given? Just the milliliter. So we have two pieces of information in there. Okay? Anytime you see this stupid slash, you should immediately fix it. And what do I mean by fix it? Why do we have a slash like that? Okay, it means division. Why don't we write 184 grams over 1 milliliter? I don't know. Why don't we do it? Isn't it easier to see the numerator and denominator when we write it like that?
Yeah.
That's a hell of a lot more useful. Why the hell do we write it like that?
Because you don't need to justify it.
Left over the units.
Writing technologies. How is the question written? On a typewriter, okay, or a computer? Are they good at dealing with fractional solves? No. Okay? Not easy to configure in a computer, so what do? We throw in the slash to try and make it easier to type. They're going after a money load out there. I totally understand. There's like 4 packages of chips all just floating. It's 7? Oh my God. Any case. In any case, let's take a look. They might have gotten it.
I know they have not.
184. Where did I place the 100 or 1.84?
In the numerator.
I don't accept that. I did not place the 1.84 in the numerator or the denominator. I placed it next to grams. Why did I place it next to grams? It's next to grams in the given information. Okay? We're looking at how that information is presented. It is presented in a way that is an attempt to be logically organized so that you can solve. So that you can go from the stupid writing technology. I'm not saying writing technologies are stupid, but the stupid writing technology that is currently being used, okay, into a mathematical writing technology that we can use to solve a problem. Okay? So now the question is, how do we use it? Yes, that gives me grams. Here's my solve. Where do I want my answer? I want my grams to be in the numerator, which means when I go through to solve, I'm going to put a line here, and what do I want to place in the numerator? Grams. Right? Am I given just grams? No, what am I given? Grams and milliliters. What are the numerical values that relate those two units? Grams is now showing up exactly where I want it to be in the numerator. Fantastic. At the same time, it sucks because what did I do? I added milliliters. So what do I need to do? I know milliliters needs to show up in the numerator in the next step. Am I given just milliliters?
Yes.
What should go in the denominator?
One battery.
1. And I know where you're going. Don't. Hi? What happens with our units? The milliliters cancel. What do we have? Grams. What do we need to do? Just multiply the numbers. We have our answer. Did I need to memorize a formula between density, mass, and volume? No. And that's typically what I'll get people right on this. So they'll get density equals mass, volume, gram mass, so D times V. Yep, they didn't get it, did they? Okay, and now they go through and solve. Well, you just did a bunch of formula nonsense that you didn't have to do if you just followed the units. With Christian, I'm a little nervous. I don't want him falling on him.
You might break.
Okay.
Are you questioning?
Does that make sense? We tracking that?
Yeah.
Hi.
Give that guy a quarter.
Do you have to have heard of the units?
No.
No. So we could get weird things like Meeks and Stoops, and everybody freaks out and goes, oh my God, I can't possibly solve this. Well, this one you can't possibly solve because you don't have the conversion factor between Meeks and Stoops.
There we go.
Now we have a conversion factor. What could we go through and do? Empty-handed.
I wish I walked in here with
Okay. So now what do we do to solve? What do we want? We want Meeks. Okay. What am I given? So I'm hearing, oh, we're given 3.4 Stoops. Where should I place 3.4 Stoops? Meeks, Stoops. Those aren't the same thing, right? That's going to be difficult potentially to decide where to place it. Potentially. For those of you like, no, I know how to do that. I don't care that you know how to do it. Focus on the process. I want Meeks. 3.4 Stoops has nothing to do with Meeks. So I would argue starting with that is a bad idea because you don't know anything about its context or what it means. What we should start with instead would be that conversion factor that does relate Meeks to Stoops. And in that relationship, I know that 1 Meek is 4.5 times 10 to the third Stoops. Do I want Stoops?
No.
So what happens? Place that in the numerator. 3.4, what goes in the denominator? 1. Now those can cancel. This one has an added complexity behind it because we have a power of 10. And where is the power of 10 located? In the denominator. One of the answer choices you get has to do with how you enter this into the calculator. You do 3.4, you hit the divide sign, 4.5 times 10 to the minus 3. There's your mathematical operators. You've now just told the calculator to do 3.4 and divide it by 4.5, then multiply by 10.3. Is that what you're supposed to be doing with the 10.3?
No.
It's in the denominator. You would have to include parentheses on it or learn some other functions on your calculator to improve success. Right? And for those of you going, well, it's not that big a deal. We could just eliminate answer choices. Some jerk-off went through, because it's really only a divide here, and it's now just a question of placement of that power of 10, has provided all possible permutations of how you could run this in your answer choices. which means you're like, yeah, I got the answer. Did you get the answer, or did you get an answer by mashing buttons? Because I can punch a bunch of buttons too and get an answer. That doesn't make it the correct answer. Does that make sense? Okay, yeah.
Would you agree it's good practice to solve all equations in our individual before we combine them to calculate?
Yes. So I believe the question is does it make sense to write out all the work with all the unit canceling and then do the math?
If there's an equation in all that, solve it before you write it out to simplify it.
Yes.
That avoids the calculator problem.
It can. Okay. Does that make sense? Okay. So with that, we're done for today. I'm feeling better about conversions, but again, the conversions require practice. You have to go home and you have to do conversions. Okay? You have to get that practice with starting that first step in initiating.